This is Phil Plait with NRAO's Astronomy Highlights of 2020.
34 light-years from Earth lies the brown dwarf 2-mass J1047, an object more massive than a planet, but not massive enough to ignite nuclear fusion in its core and become a true star. It has a very thick atmosphere, with fierce winds blowing through it. But how do you measure them to find out how fast those winds are blowing? One way is to measure the overall rotation speed of the object itself, called the bulk rotation, and then measure the rotation speed of the atmosphere. The difference is the wind speed. Using the Very Large Array, astronomers measured the radio waves coming from the brown dwarf, knowing that these are tied to its magnetic field, which in turn is rooted deep inside the object. They found it has a period of 1.758 hours. That's the bulk rotation period of the brown dwarf. They also used the Spitzer space telescope to measure the infrared light coming from the upper atmosphere of 2-mass J1047, and found it brightens and dims on a 1.741 hour cycle. This is due to the atmosphere's rotation speed, carrying storms and clouds into and out of our view. The difference between the two is due to the winds. Knowing that, plus the size of the brown dwarf, they find the wind speed is a brisk 2,300 kilometers per hour, more than 5 times faster than the fastest Earth tornado on record. This technique should also work for measuring the wind speeds on exoplanets. It's amazing! With the VLA, we can measure the weather on objects quadrillions of miles away.